Hello, I'm going to walk through the second lesson of the Marlowe Starter Kit. This uses the Marlowe Runtime REST API to operate a zero coupon bond contract. The previous lesson showed how to do that at the command line. Now we're going to do it over the web with REST. So the previous lesson talked about how to get the Jupyter Notebook started and some of the mechanics around that. So we're not going to repeat that here. We're just going to open the second lesson. The contract is very much the same as before, except we're going to use role tokens here. So in the first lesson, we used addresses. The lender and the borrower each had addresses. Um, in this lesson, they're going to have role tokens. So role tokens are NFTs that are used to authorize Marlowe transactions. Aside from that, everything is the same here. So you can work with this contract in the Marlowe playground. Um, you'll see we have the word role here, where previously we had address, but everything else is the same. And the preliminaries are the same. We need to make sure that we have a node socket, that we know the network magic. And in this case, we need to know where to reach the web server. And then the lender has a set of keys and the borrower has a set of keys. So to get all these variables set up, actually first we're going to just clear all the cells so that we can start fresh here. And we're just going to execute this cell. It's going to set environment variables and it's going to give us a bunch of information. So we see it found the node socket. We're using the pre-production network that has magic number 1. We're running locally. There's the port for the web server, and there's the URL for the web server. Now, as we did before, we need keys and addresses for the lender and the borrower. We just want to make sure they have enough ADA, so they have 1,000, and that's fine. If you wanted to look at them on the Cardano Explorer, you could do that. We can click here, and you can see that briefly. They have 1,000 ADA. The borrower is the same deal. They have 1,000 ADA. Good. And then the contract design is the same as before. We're going to have principal of 80 ADA and interest of 5 ADA. So we'll set variables to that for convenience. We're going to start the contract off with 2 ADA as to satisfy the minimum UTXO requirement. That's the same as before. And then we're going to use some time constants here. So first alternative, we could actually design this in the playground. I'm not going to do that here, but you can visit Marlowe Playground. You open an example. You choose Blockly in the zero coupon bond, send it to the simulator, fill in the loan deadline, the payback deadline, the 80 principal and the 5 interest. And then the key thing is you click download as JSON. So essentially, anytime you've designed something in the playground, go to the simulate screen, fill in all the parameters with the actual values you want, and then click download. For convenience here, we're just going to use the Marlowe CLI tool to fill in a template here. So we need to know the current time. And then there are 2 deadlines. One is for the lender to deposit the principal. The other is for the borrower to return the principal with the interest. And we can create the contract. There's a contract file. And then if you wanted to understand more about these template commands, you can do the help on them. And then once again, we can look at the contract and we'll see it's using role token here where it used to use address in the first lesson. It's really the only difference. I'll just remind you, it's always good to check the safety of a contract, especially if you're considering running it on mainnet. So we have a series of steps here from like just understanding what's going on, understanding best practices and security, using the playground, which can really tell you a lot about the safety of your contract. You can make sure it's doing what you really intend to when you've written it. We have an analysis tool, and then, of course, the Cardano testnets let you try things out in a safe place. So now we have to create the contract. So the first thing, since we're going to use the REST API, we are going to have JSON payloads in the requests. So we're going to create the request here. We have the contract itself. We're saying we're using Marlowe version 1. Here's the minimum UTXO. We don't have any metadata or tags. And we want the role tokens to be minted in the creation transaction. So we have to say the role named lender in the contract is going to actually live at this address. And so when the role token is minted, it's going to be sent to that address. Same with the borrower. It's very important if you have a contract that has roles to actually mint the role tokens. Otherwise, you're not going to be able to operate the contract. So we're going to create this. This is what the payload looks like. It's mostly the contract, but it has that other data. And then we're going to use curl. You could use any tool that lets you do HTTP posts. And the payload is that request JSON that we just put here. We're going to store it in a response JSON file. And in the header, we have to tell it the address of the person who's going to be operating and signing the contract. So here's the curl command, and we're printing out like the results here, which is quite a bit of binary data. We just have the contract ID, but we also have the whole transaction, and it's kind of large because it includes the minting validator. We want to extract the contract ID from that for later use. So here we go. That will identify the contract throughout its life cycle. And then we need to pull out of that big response just the transaction body that needs to be signed. So we're using the JQ tool to run a query on the JSON and just pull out the unsigned transaction. And then we have several options for signing this: Cardano CLI, Cardano Wallet, either at the command line or using its REST service. We could use the hardware wallet command line tool. If we have a SIP30 wallet that is Babbage compatible, we could use that in a web browser, or we can use the Marlowe CLI tool. Since this tutorial is really not about signing, we're going to use the CLI tool because it's very convenient. And I started that transaction. We gave it the unsigned transaction file. We gave it the signing key of the person signing it, and we told it to wait up to 600 seconds for the confirmation. And we actually got the confirmation quite fast. So we'll compute the address on the Explorer and then take a look at the contract. So we can see the 2 ADA was deposited at the contract. And then at the lender, we can see that they lost a little bit because of the fee, but they also received the role token. So if you decode this hexadecimal here, you're going to see that that spells the word lender, which is the name of the role. And this is the policy ID for that NFT. And that policy ID is called the roles currency for the Marlowe contract. So this is basically going to be used to authorize transactions. We'll similarly look at the lender, and so they have their own role token. This hexadecimal will spell out the word borrower. So let's take a look at this in an Explorer. We have to wait a little bit for it to be confirmed and processed on the Explorer side. Okay, there it is. You can see the fees are a little bit higher for creation than, or when you're using role tokens than when you're not, because you're paying a Plutus script to do the minting. And here are the UTXOs. So we can see the 1,000 ADA coming in. There's 995.5 change. 2 ADA is going to the contract address. There's the datum. And then the borrower gets a roll token and the lender gets a roll token. So if we click on the borrower, we can actually, see there's their roll token, there's the policy ID, and we can see the same for the lender. So they each have their roll token. And that it's really important to keep track of that roll token because that is the authorization for transactions in the contract. Now, Marlowe Runtime, the web server, provides a GET endpoint to learn about what's going on with the contract. So we can basically call this endpoint, give it the contract ID. So we're going to compute that URL and you can see what it is. And then we're going to just call that endpoint, and then you can see information about the contract. It comes back in JSON, but we're converting it to YAML, so it's a little bit easier to read. But it basically tells you everything that's going on in the contract, gives you the contract, any metadata, there's the roles policy, initial state, things like that. So for the next step, the lender is going to deposit their 80 ADA. And so we have to craft a JSON request for this. So you can do that by hand with any tool. Marlowe CLI actually has something that will do that for us. So we're going to use that. Here are the instructions, and I'll just execute the command. We say lender. They're the party. They're depositing into their internal account in the contract. The principal is the amount, and we're going to store this in this input2.json file. And that's what it looks like in YAML format. We're going to package this together into the request for this transaction. We give it the Marlowe version number, the inputs. We're not going to attach any metadata. We could if we wanted. And so there it is. And then, as we did before with creation, we use a HTTP post to actually do the creation. And so we're putting it to transactions under that contract URL. And there's the response. This is basically the datum plus some other stuff for the transaction description. You can see the contract ID and the transaction ID here. So we're going to extract the actual unsigned transaction out of that response as we did before. So it's going into this file, tx2 unsigned, and then we will be submitting that once again with Marlowe CLI. So we give it the unsigned transaction, we give it our signing key, and we say wait up to 600 seconds for the confirmation. Okay, there's the confirmed transaction. We'll compute the Explorer address, and then we'll take a look at what's going on here. So at the lender, they're down about 80 ADA from the previous transaction, and they have the roll token again, it's because they need that. The actual contract, this has the 2 ADA in it, and now in the first lesson when we did this transaction, the 80 ADA was actually paid directly to the borrower. But when you're using roll tokens and roles in Marlowe contracts, it doesn't actually go directly to the party. It goes to the roll payout address. So this is another Plutus validator that Marlowe uses. It's a very simple validator. It basically holds funds on behalf of someone. So here you can see there are 80 ADA here. And if you were to analyze this, the datum that went along with this datum hash, you would see that it says that this 80 ADA belongs to the borrower, and they're the one who can redeem it. So we'll withdraw it in just a second. We can once again view the contract. There's a little more data here. about that transaction. You can see the inputs for the deposit, for instance. So now we have to withdraw that from the roll payout validator address into the actual wallet of the borrower. The request is very simple. We just tell the contract ID and that it's the borrower. So that's what it looks like in JSON format. And then the endpoint is called withdrawals. So we basically just post to that, and we'll take a look at the response that comes out. Here's the transaction, and once again, as before, we'll extract the unsigned transaction and we'll submit it. The key thing here is the borrower is redeeming things, so they have to sign it. They have the roll token in their wallet, and that's going to authorize their withdrawing that money that's held on their behalf. And so once again, we'll just wait for confirmation here. There it is. There's the Explorer address. And there's the 80 ADA at the borrower address. Now you have to add this up a bit because it's been combined. The UTXOs have been combined for efficiency, but if you total this up, you can see we're at about 1,080. And actually, I forgot to actually show you this transaction number 2 in the Explorer. So maybe we'll take a look at that, or actually we'll look at this one first. We'll just have to wait a little bit. Okay, there it is. And so you can see quite a bit going on here. This was the UTXO at the payout validator. So it had that 80 in it. And the borrower originally had a wallet with 1,000 in it. And they also had their roll token, the borrower. So they're putting all this into the transaction. This is what they want to get out of it. This is basically funding for the transaction. They'll get change back. And this is the authorization for the withdrawal, that they have that token. And so the output is the ADA that they withdrew, and then they get their roll token back. And you can see, so we're at 1,080. So they basically pulled that out, and there's a little bit of fee going on here. And what we can actually do, since I forgot to show it before, is let's look at the previous transaction. So this was transaction number 2. And you can see there were 2 outputs to Plutus scripts involved. This 2 ADA was to the Marlowe contract, the main Marlowe validator. We call it the semantics validator sometimes. And this 80 was to the roll payout validator that was holding things on behalf of the borrower. And you can see in this transaction, the lender had authorized it and they got their token back. So it's quite a bit going on in that transaction. It's very instructive. So now the borrower can repay the loan. And so this is just another deposit. We did that before. It's going from the borrower into their account, and they're paying back principal and interest. We'll construct the request as we had done previously, and then we'll ask Marlowe Runtime to build the transaction for us. So it gives us some data and then the actual transaction body. We can pull out the transaction, sign and submit it. In this case, it's the borrower signing and submit it. And then we'll be able to look at this on the blockchain in a few seconds. Okay, it was confirmed. We'll compute the URL, and then you can see the borrow, or if you add this up, they've got about 5 ADA less than originally. And the lender didn't receive the 85 ADA yet, but what they did receive was 85 ADA at the roll payout address on their behalf. And so that's sitting here at that address. And let's take a look at this transaction in the Explorer. It's already on the Explorer. So we can just see what's going on is the borrower, they had about 1,080. They were operating on the contract, so they're consuming that. They were authorizing with their roll token. And then as the output, they end up with about 994. They still have their roll token. And then this 85 ADA has gone to the roll payout validator. And you see there's no output to the contract address because the contract is finished. It's done its work. We just have this residue at the roll payout address. And then we can take a peek at that. There's not much left in the contract. We have this input, and output contract is null because the contract is finished. So we're going to instruct the transaction to make the withdrawal of principal and interest for the lender. So we just say the roll is the lender, and we just post that. The lender has to sign it because they have their roll token. There's the transaction. Extract it into a file, sign and submit it, and then we'll take a look at that. There's the transaction. We'll compute the URL. We'll see that the lender has about 5 extra ADA, and the various fees have been involved, and we can look at this transaction. There's the transaction, and we can see the 85 ADA being consumed. The lender had about 915 ADA in their wallet. They also had their roll token, and after the transaction, they received the ADA. They still have their roll token, and you can see they're really not up a lot because they've paid various fees that kind of ate a lot into that 5 ADA. Let's take a look at their address. We can see maybe the total here. There's the total. So they're a little bit up, but not a huge amount. And they still have their roll token. That could be reused. It could be burned to recover the min UTXO that's at it. And then I think we can also take a look at the previous transaction, and we'll see I'll just take a look at the wallet for the borrower. You can see they're down about 5 ADA, and they actually have a roll token, so they got a roll token sort of out of this. And if it bothers you that the contract creator basically gave them an ADA when they gave them the roll token, you can actually build that into the contract so that that's deducted later on, but we haven't done that in this particular contract. And then the other thing is, if you want to see all the things you can do with the REST API, it supports Open API, so you can just make this call and you get just a very long printout of all the description of the Marlowe runtime endpoints. So there you have it. Thank you.